All right, so I'm making this video for a couple reasons. Number one, because I'm trying to wrap my head around what's going on and being able to verbalize it and go through everything one line at a time helps me do that. Number two, because obviously we're all at different stages in our progression as far as, trying to solve this problem. And so hopefully if anyone is trying to catch up, this will help. I am going to assume that you've already watched the TPM2 policy or video. There are two of them, probably best to watch both of them. You don't need to worry about the policy authorization one. We're not doing that. I actually asked Nick directly about it, and he said he would prefer to do this, so we are sticking with that. And honestly, this is probably easier. So what I've done is I've taken all of the kmyth seal code, and I put it all into one script here. So essentially kmyth has like over 1,000 lines of code, and we could really kind of minimize it down to maybe like 150 or so. So all I have in this file right now are two functions. One is called print bits. I'll talk about that later, but it actually doesn't even do anything relevant to kmyth. And then the other one is main, which is, the function that we're calling. So what I did was I hard-coded some values in, and I got rid of all of the error checking. I was really trying to, simplify this as much as possible so we don't have to worry about details that really don't matter toward, our objective. And I tried to keep all the variable names the same. So hopefully when we actually come up with a solution, well, what I'm trying to do is work on this script right here, and I'm going to try to come up with a solution using this script, and then take that and translate that back into kmyth. So all the variable names will be the same. Hopefully that will make it a little bit easier to do that. So right off the bat, we have a string here called inpath. This is the path to the file that we're sealing. If I ls here, I don't have anything in here. And if I go to desktop, this is the file that I want to seal. All it has inside of it is the text IDK. So the out path is going to be the output file when we are done writing everything. So I'm going to go ahead and run this here, and it's going to be called idk.ski. So now if I ls, you can see we have idk.file. So if I go to kmyth2 idk.ski, we have the sealed file. The next thing I have is an array full of the PCRs that we're going to be using, 0, 1, and 2 for this example. And the size of that array is 3. In the kmyth code, they take a string and they parse through it and all that. We don't need to worry about that. We can just put it all in an array, cut out like 50, maybe 100 lines of code right there. Here we have the owner auth password. These are all, pretty much all of this stuff right here. From here all the way up to here is just a whole bunch of variables that I'm initializing. So it's good to know what they are, but they're not actually doing anything right now. The owner auth password is if I had a password for the storage root key, not the storage key. From the other video, we have the storage root key. That is going to be wrapping the storage key, and that is going to be wrapping the idk.txt file. In the context of kmyth, this would be a symmetric key, and this symmetric key would allow us to encrypt your entire hard drive. And we would use a symmetric encryption, and then we're going to encrypt this symmetric key using the storage key inside of the TPM. So here we have a string owner auth password. Right now it's just empty, but if we had a password we wanted to put in, like password 123, this would be saying that we want to write in as part of the policy that on the storage root key, the only way you can access it is if you type in the password and get the password correct. But we don't need to worry about that. This is going to be empty. And likewise, this auth string right here, which is null, is going to be the same thing, but for the storage key. So again, it's just a password if we were going to have password 123. And we wanted to, make sure that people type that in before they can unseal something using the storage key. But we're not really worried too much about that. So we're just going to keep all of that null and empty. Here we have the expected hash, and I'm not using it. It's a variable. I haven't used it anywhere in this code. As of now, all I'm doing is a regular policy PCR seal. So this is exactly what kmyth already has. I haven't added any functionality. I'm just trying to strip everything down to, the bare bones and hopefully be able to come up with a solution for this script and then take that and translate that into kmyth. But this would be, the golden PCR value that we expect after we do a firmware upgrade. This is, a hash value that I know how to get it. And there's nothing special about this other than, when I created the tutorial, I generated a random SHA-256 digest. And from playing around with TPM2 tools, I know that if I have, PCR index 0 and the hash is, all zeros, and then likewise if I had PCR index 1 and PCR index 2, and the hash is all zeros all the way up to 64 characters, I think. But if I took, any one of these values and I combined it with this random hash that I just, happened to randomly generate using an online calculator, and if I were to combine this value with this value, then I know that the output is going to be this right here. And likewise, it's going to be the exact same for PCR 1 and 2 because we're combining this value with this value. So what we would have is PCR index 0, 1, and 2 all having this value inside of them. And then when we hash all of those together using the golden PCR and the binaries or whatever other stuff they do, then we end up with this string right here. So to recap, we're starting out right here, then we're going to do a PCR extend, and we're going to take in, this single value, and then, maybe the PCR register for 0, and then do that again with 1 and 2, and then this would be the output. And then we hash all those together, and we would expect that this is the output. And this is the thing where when we say we want to do a policy OR, we want to unseal the data inside of the storage key if PCR value is equal to current PCR values, meaning whatever it is we have in the PCR registers right now, or if PCR value is equal to this hash right here. And ultimately, this is what we're trying to do. But as of right now, this is nothing but a variable that I never use. I don't even need it in the code. So, you don't need to worry about it too much. But, in the future, we got to come up with some way to actually test this out and make sure it works. But moving on, again, these are still a bunch of variables that we're creating. This is data and the data length. So this is going to be the actual input data that we're getting from the text file. So if I go to my desktop and I get this IDK file right here, you see IDK. The input data is going to be something like IDK with a new line, and then the data length should be equal to 3. Right now, we're just initializing the variable. We haven't actually set it yet. And then we have this right here, which is the output. And the output is when we go here to the binaries. Let me run the program one more time. And if I look at my file, this is the output.ski file. So the output is all of this text right here. And then the output length is going to be the length of this text, however many characters or bytes. So you can see here we have the output length. And note that output is a pointer, and output length is not a pointer, but it's a size t. And so we also have the address of that, and I've called it output address, but I'm storing the address of the output inside of this variable, which is a pointer to a pointer, because this is a pointer. And here we just have a pointer, which is pointing to the address of the length. And there's a reason I kind of did this, and I'll talk about that later. But for now, we're just creating a bunch of variables. Here we have the auth bytes and the auth bytes length. So there's the owner auth bytes, and then there are the auth bytes, and the auth bytes are for the storage key. Again, that is nothing more than like that password 123. And in this particular scenario, we're not worried about it. So they're just variables that are ending up in the program because kmyth has them in their program. We have owner auth bytes. I don't even think we need this. I might just go ahead and delete that because it's not even being referenced anywhere in the program. So now, again, all we've done is create a bunch of variables. Some of them are hard-coded. A bunch of them are just kind of null and empty at the moment. It's good to know what they are, but we haven't really done anything. The first thing we're doing is reading the bytes from the file. So it's going to be reading in the bytes from the unencrypted IDK file right here. And it's going to be writing those bytes to this variable right here, which we had already talked about, but this is basically going to hold the text IDK with a new line there, and then data length is going to hold the value of 4. So we don't really need to know what the details of this function are. All you need to know is that inside of data, we have this string, and inside of data length, we have this 4. And we press on. So here I'm doing an actual kmyth seal, which is the actual kmyth seal function inside of kmyth, which would be found if you go to kmyth seal unseal, and then kmyth _ seal. This is that function right here. But I've taken all of this code, which it's a lot of code, and I basically compressed all of it into kind of the things that we actually need. So I'm calling that function right here, but we're just not using a function anymore. But if you look in here, the first thing we do when we call that function, we do TSS2 system context. And then the second thing we do is this function right here, init TPM2 connection. That's what I'm doing right here. TSS2 system context, init TPM2 connection. So all we're doing here is creating a variable, which is going to hold the context of the connection. This is going to fill in, kind of the information about the user login, whether they're using a virtual TPM or a real TPM. Again, these are functions that we don't really care about the details. Just think of it as, starting up the TPM and, we're putting some of the metadata into that context item. Here we're doing TPM2B auth, owner auth. Again, remember that owner auth is referring to the storage root key. Whenever they have owner, they're referring to the storage root key. Whenever they have object, like here, we're talking about the actual storage key. And I'm not going to mess with this line, but I'm pretty sure it's the same thing as saying, object auth val dot size is equal to 0. So they're just, using one line to declare it and then declare what the value of size is, as opposed to up here where they did it in 2 lines. But they're the same thing. This is referring to the storage root key, the authorization needed in order to access the storage root key. And then this is referring to the storage key and the authorization needed to access the storage key. So here we're doing create auth val. Again, we don't need to know all of the details. It's calling a function. It's taking in those passwords, which we didn't actually write one, but if we did, it would take in, password 123 and then the length of that. And it's going to write whatever it writes into the value of object auth value. This is going to be the variable that holds the information about that password. But again, not really important to what we're doing. We press on. So here I'm creating the ski file, and they actually do this a little bit earlier if you're going to step through and kind of follow what I'm doing from the kmyth code into what I'm doing right now. But the actual order of everything doesn't really matter. All I'm doing is creating a ski object, and if I go ahead and type in ski dot, this is all the things associated with that object. So you can see we have a PCR list, we have a cipher, we have the encrypted data with a private key, public key. So all this is a object in RAM holding all of the details so that when we come here to write this file, all of that stuff is going to reach into that, ski object and then write all of this data right here. But you can see we have all the same information, PCR selection. We have a public portion of the storage key, a private portion of the storage key, the cipher. So that's all it is an object holding those values. Here we're declaring that the cipher that we're using for the symmetric encryption is going to be the default cipher in kmyth. And this is what the cipher is called. I don't know exactly what it is, doesn't really matter. In kmyth, the user would actually be passing in a cipher, and by default, if they don't pass anything in, they would get defaulted to this, but we don't really care about the cipher, so we're just going to go ahead and use the default regardless. And press on. The next thing we do here is Init Pcr Selection. And this is going to take that array of PCRs and the length of that array that we see up here. And it's also going to take in the context, and it's going to write the list of the PCRs that we're using into that ski file. Now, the way they do this, as Jared has mentioned before, they use a bunch of bits in order to detect whether or not you're using a certain PCR index. So this is what I have here just to visualize that concept. All I've done is create, this integer test, and you don't need to know all of the details here. I got this from looking inside of the PCR selection. But if I do this print bits function, it takes in, the size of that integer and the address of the integer. And when I run it, it prints out this value right here. So basically, this is from the most significant bit to the least significant bit. And if we're using a certain PCR index, we give it a 1. Otherwise, we give it a 0, saying that we're not using it. So here you can see our PCR selection is 0, 1, and 2. This is a 1 for 0, a 1 for 1, a 1 for 2. And if we were to do something like add in a 5, we would have to make some changes to the code. But ultimately what would happen is we would have a 1 here for 0, 1 here for 1, 1 here for 2. We would have a 0 because we don't have a 3 up here. And then we would have another 0 because we don't have a 4. But then this fifth one would be a 1 to indicate that, we're using that PCR index. Now, this code right here is not part of kmyth at all. I only put it in here to visualize it. So if you don't want it, you can delete it. And you can also delete this print bits function. That doesn't really have anything to do with the code itself. It's just a way of visualizing what's going on. So pretty much everything we've done so far doesn't really even matter, honestly. I mean, we're passing in this path. We've, assigned our PCR selection. Like, none of this actually matters to complete, the objective that we're trying to complete. All we've done is create a bunch of variables, kind of initialized a couple things. We created this, ski object. It's good to know that the ski object has all these items on it, or in it, if you prefer to think of it that way. But now this is the actual important part, and this is the part that we have to make modifications to in order to solve the problem. And so this is where we actually call the create policy digest function. So if I go to TPM2 interface, you can see we have the create policy digest function here. And this is where we're going to have to make some of these changes. But the first thing they do is create this TPM2B digest. They probably could have come up with a better name for this, but it's the object auth policy. And they initialize the size to 0. And then the next thing I'm doing here, I'm creating this TPM2B digest policy digest underscore out. And that is nothing more than the address of this object auth policy. So this is just a pointer to a digest, which is nothing more than a string of letters like this. And what I'm actually doing here is trying to kind of replicate the function call. So if you look at the actual create policy digest function call, you can see here we have the SAPI context. Here we have a PCR list, and then here we have the address of the object auth policy. But then when we go into the actual call itself, you can see that these data types, they're a little bit different. Like, for example, here, we're passing the address of object auth policy. So really, we end up with a pointer to a TPM2B digest, even though object auth policy is a TPM2B digest. So what I've done here is replicate that. So I've created the TPM2B digest object auth policy, and then I've created this policy digest underscore out, and that's the address of the object auth policy. And it's just a pointer to that address. And I've done a similar thing here, ski.pcr list, and then the output is a TPML PCR selection, and they call it TP PCR list. So what I'm trying to do is kind of replicate those functions, and I'm using the exact same variable names that they're using. But note that this was before we called the create policy digest. And then these are the items inside of the create policy digest. And that is important because, they're slightly different. This one is, a digest, and this one is actually a pointer to a digest. And there was one other argument, which is the SAPI context. So you can see here it's the TSS2 system context. And if you look here, you see that this is a SAPI context. It's not the address. It's literally the same object. And if you come in here, you can see that this is the same data type. So that is why I don't ever call this again. I'm just reusing the same variable throughout. And hopefully that's not too confusing. Again, I'm not making any function calls to create policy digest. I'm only trying to replicate the code of what's going on inside of it. So the very first thing that happens inside create policy digest is that you create a session called trial policy session. And if you come in here, you can see that's the very first line right here. So hopefully you don't need to look at these files at all, as long as you can read through from top to bottom here and kind of follow what's going on. And this is what I was talking about earlier. I said I'd come back and talk about it. I did the same thing up here, where you can see here I have output, but there was actually a function call that they made, so I had to create the output address here. And this one is actually a little bit more confusing because they use the variable name output as the input to the function, and then they also use the variable name output as the argument in the function. So I had to call this one output address in order to differentiate them. And then likewise, this is output length address. But hopefully if you read this from top to bottom, it should all be fairly clear what's going on. It just might be a little odd, and I'm kind of explaining why it's like that. So once again, this is the important part. Everything up until this point, not really that important. We're creating the policy digest. This is the address of it. Here is our selection of PCRs. And this is a little bit more complicated than what it should be, but you can just think of it as this right here, where again, we just have a 1 for all of the PCR registers that we're actually filling against. And then moving down, we're creating a session file. It's called trial policy session, but it doesn't actually know that it's a trial policy session yet. We haven't actually passed it anything. This is just a variable name they used. Here, a bunch of stuff related to nonces, not relevant at all, or at least I don't think it is. I know Trey wasn't in class when we talked about it briefly, but it's kind of like, when you lose your password and you do a recovery and you say, I forgot my password, and they send you an email. Well, they have a number associated with that email. So once you click it, you give it back that number. And then once it receives that number, it knows, okay, somebody already clicked this, and then if somebody else comes along, finds that link, they can't also reset your password. It can only be reset one time. So a nonce is a number n, and it's being used one time. So n once. But again, not important. Don't need to worry about it. I kind of lied. This was important, but this is the really important part. And this is the part where we're actually calling the apply policy function, and that is inside of the create policy digest function that we're doing here. So the very first thing we're doing here right before that apply policy is we're doing start policy auth session. The details here don't matter. All we're doing is initializing stuff. We're passing in the context. This is the session that we created up here. It doesn't know that it's a trial policy session yet, even though it's called that. So we have to pass it in the data type. And if we were doing a policy session, recall from the policy or videos, the trial session is to set everything, and then the policy session is to make sure that the PCR values actually match and do the unseal. But since right now we're just doing a seal, we're going to use tpm2 se trial. And here we have a tpm2 handle, which is a way to refer to an object inside of the TPM. So when we created this object up here using the start policy auth session, it took in this variable right here, and it assigned a couple things to the trial policy session. And if you click on dot, you can see there's a bunch of associated variables. For example, the nonce, the handle, the type of session that it is, which we have right here. So this is a object, and I'm doing the apply policy function call, which is why I'm referring now to the trial policy session.session handle, and then storing that in this policy session handle variable. And then this is another variable. Remember, again, we're doing a function call to apply policy at this point. So these are the variables being passed in as parameters. Policy session PCR list is equal to the PCR list that we have on that ski file. Again, you could just think of it like this, even though it's not quite that simple, but that's relevant for now. So now that we're actually inside of this apply policy function, we have an auth command and an auth response. The TPM2 really doesn't do anything but sit there and wait for people to send it commands and then give responses. So these are just variables that we need in order to perform that functionality, but we don't really need to know all the details. So far, we haven't actually made any calls to the TPM, and this is actually going to be the first one that we make to the TPM, and you could tell because it has the TSS2 here, meaning that it's from the system API or the SAPI, and this is the stuff that if you would have to look up on GitHub. And if you need to find this code, this would be under the GitHub. For example, right here we have the policy auth value. Sorry, this is the one that we're actually making a call to. And then these are the arguments that it takes in. But you would have to actually look up the documentation on the TSS SAPI spec. And you could probably find a couple more details about it. There's really not a lot of great documentation on here. But also keep in mind that every single call from the TSS is nothing more than a call that is happening in the TPM. So we go to the TPM2 spec, and we come down here to commands. And if I type in policy auth, I should be able to find it eventually. They're talking about the actual function itself. These are the data types. All of these under this line right here are arguments that go in. And then this is the type of response that you can expect. And these are some slightly more lower level details, but everything you see here is an assembly level call. And the system API, the TSS2 SAPI, is basically taking all of those assembly language calls and translating them into C. That way we can, use C in order to make calls the way we're doing right now. And that's really all they're doing is translating C code into assembly code and then passing it off to the TPM. And I cut some of this code out because I'm trying to, keep everything to the bare minimum. But if you're going to be playing around with this, it might be useful to know that you can do this. If you create this TPM2 RC variable, which is a response code, and then you can say something like, if RC is equal to TPM2 RC success, and then you can do something like printf success. Basically, it is getting a response from the TPM and storing it in this variable. And if this prints out, then that means that the call was successful. So if I go ahead and run this real quick, you can see it says success, meaning that the call worked, but I'm going to go ahead and get rid of that. But that might be good to know if you're trying out some of these functions and you just want to, give yourself a sanity check and make sure that everything is working. And there might be an easier way to actually look inside of what RC is. That's kind of my hacky way of doing it, because if you, drop a breakpoint and then run the debugger, it doesn't actually say TPM2 RC success. All it says is 0, and that's not exactly helpful. There's probably a better way to actually view what the response is, but for now, that's good enough for me. But here we have the TPM2B digest. We're giving it a empty digest. So keep in mind here, this is just the variable name. So I can do another one, TPM2B digest, and then I can call this one my expected digest. And if I do expected digest, and it's probably a little bit more complicated than this, we probably have to translate it into binary or hex or something. But in theory, we should be able to just fill up the buffer with our expected PCR hash. But I'm not going to do that yet. Right now, all I'm doing is what kmyth currently has in their functionality, and they pass in an empty digest. Here they have the TSS sys policy PCR, and it's passing in the address of that object. But again, remember that this could be PCR expected digest. And if in that buffer we have some value for the expected PCRs, then we should be able to associate that with, the PCR index values that we're giving it. So coming down here, this is policy get digest. Right now, I believe the policy is living inside of the TPM, but we want to bring it back so that we have access to it in our own RAM. And so we're passing it this. Again, there's a lot of arguments here. I'm kind of waving my hand at some of them. These are not really important. They're just, necessary to do what we need to do, but we don't need to know anything about them. The policy session handle is referring to this particular session that we're working on. This is the context that we've been working with the whole time. And then here we have this empty digest that we're passing in. And then here we're just passing in that list of bits saying that, okay, this is PCR index 0 or 1 or 2. But then when we come down here, we're getting policy get digest. Again, we don't really care about the command or the respond auth. This is the same, session handle to reference the trial policy that we're working on right now, the context we've been using the whole time. This is the policy digest out. And I believe the actual policy that once everything gets hashed together, it gets written into here. Reminder that policy digest out is this right here. So it is a pointer, and it is the address of obj policy. So it is going to be writing the overall output digest of the policy into this variable right here. Then after that, they flush the context. All they're doing is wiping it from the TPM2 main memory, which you saw plenty of times in the policy or video for TPM2 tools. And this is really it. This is like the only critical part of this program that we need to modify. So coming back to the documentation, they do have different data types here, which is a little odd, but I've also noticed here in the policy PCR, they're using different data types as well. So when we called policy PCR, we were passing in our session, even though it wasn't this particular TPMI SH policy. Okay, so this is actually the handle. That makes sense. All right. So we would need to do policy OR here using the handle to the policy session, the system context, which we've been doing anyway, the auth command and the auth response, which we don't really care about. And then here we have the TPML digest. So we do need to figure out how to get this data type here. There's some step in between, because obviously here when we do policy PCR, we're doing a TPM2B digest. And then here we have a TPML digest. So we kind of need to figure out the steps to get this particular variable, what it needs to be filled with. But I think, and I'm not 100% sure, what we can do is call this TSS2 policy PCR. We're calling the policy session handle. Then we're doing it again with another policy PCR, except we would create another expected digest somewhere up here. And then finally, we should call the TSS2. Then there's probably some intermediate step here before finally calling the TSS2 sys policy OR. And we'd be passing it in a lot of the same arguments, not all of them. The SAPI, the session handle, null command ops. This would be different. And then somewhere in here, we would have phash list, whatever that is, which is a TPML digest data type. Then hopefully we can call this policy get digest, And again, it will write that policy into this digest out, and then we can use that when we create the storage key later on, which is done right here. This is the obj value, which, remember, this is the actual item inside of the address. This is the pointer to that address. And 2 notes. Number 1, if we conceal doing that, we still, I think, need to do a modification to the unseal to make sure that we are properly unsealing against both of the PCR values, at least according to TPM2 tools, because they have an extra step for unsealing when you're using a policy OR. The other note is, if this doesn't work, I think it has to do with the actual session flow. So we might need to create a new policy auth session and kind of run through a lot of this same code. One for the policy PCR where we have the empty digest, one where we have the policy PCR where we have the expected digest, and then one more time with policy OR with all of these variables right here. Now, that being said, I would try this method first. Number 1, it's a lot easier. Number 2, it kind of makes a little bit more sense as far as the way they have the documentation. But if that doesn't work, there is still another thing we could try out. So the good news is that is really all that matters. The rest of this code, we don't need to worry about too much. Let me go back and undo a lot of the changes I made. And I'll go ahead and talk through the rest of this, even though it's not that important. The code you see here is after we've returned from doing that create policy digest function. Again, not as important as the stuff up here, but they're just creating a handle, one for the storage root key, one for the storage key. Ignore this right here. I put that there, playing around with things. And then here we're just getting the handle for the storage root key. The details aren't super important, but assuming that we get that handle, we pass that handle to create and load the storage key. Again, if you remember from TPM2 tools, one of the things we pass to a storage key, a non-primary key, when we create it, is the parent, and the parent is this storage root key. Once again, passing the context. I've already kind of forgotten, but I'm pretty sure this is to indicate that we're using the owner hierarchy when we're creating this key. Also, my bad, I might have misspoken. Earlier I said that policy digest out is a pointer to, I might have said object auth val. That's wrong. It is a pointer to object auth policy, which is the actual policy that contains the PCRs and all that other stuff. But I haven't looked through all of this code inside of this function, but it looks like we're passing the storage root key handle, the parent key, the SAPI context. This is indicating that the parent is an owner key using the owner or storage hierarchy, same thing. And this is referring to the actual storage key, saying that this is also an owner or a storage key. I'm not entirely sure why they pass in the PCR list again. You can look through that code. I might later, but for now it's not that important. This is the actual policy that is required in order to open the contents inside of the storage key. And then here is the variable that we end up storing the storage key in, or rather the handle that we're referring to it by in the TPM. And then when we eventually write everything to a ski file, it's going to be separated into the private and public portion. And here they're just doing some cleanup. Note that the reason I wrote this is because we're actually, I think, returning to a higher level function call. But this is the input and the input length. All this is the data that's going to be written to the ski file. Here we don't really care about all the details, but they're basically doing the symmetric encryption on all of the data inside that file. And then ultimately, they do a bunch of garbage cleanup. They write everything to the file itself, and we press on.